Page 73. Make sure you write your name, the period, and the date. Quick review. For our symbols in this chapter, we have capital W, which is work, and your SI unit would be in joules. You can just write capital J. Notice that that's similar to the unit for energy. Force is capital F. The unit is in newtons or capital N. Small letter D is displacement. Sometimes it's written as distance or height in your problem solving, and it is measured in meters. So anytime you will see centimeters or any other units aside from meter, make sure you will convert it back to meters. Angle theta, that circle with the dash, is in degree. So how do we know the value of our angle theta in this work problem? The general equation for work is force in newtons times cosine of the theta times the distance. Most likely the theta is not always going to be given, so you need to understand the relationship of the direction of your distance with your force. So in the first scenario over here, distance is at the same direction of the force, then your cosine theta will be 0. So they can both be to the right or they can both be to the left, downwards or upwards. Notice that the second example over here, force and distance is going up, so your theta is still in 0 degree. What will happen if force is in opposite direction as your distance, such as in the case of friction? Then your theta will be 180 degrees, opposite direction. If your force is in 90 degrees to your distance, what's an example for this? Say for instance, you're lifting up something or carrying something while moving forward. That means that your force is going up, but the direction of your body is going forward. So it makes a 90 degrees between force and distance. In that case, your angle is 90 degrees. In the last example over here, if it's tilted, if it looks like an inclined plane, such as pulling the leash of a dog, then your angle will be, it could be 45, it could be 30, it could be 20, depending on what is stated on your problem set. Quick values over here. If you plug in cosine 0, it's not going to be 0, but the value in your calculator will be 1. Cosine 180 will give you a -1, and cosine 90 will give you a 0. Important thing to remember on your calculators, make sure again that you check your mode, you press your mode all the time, and remember to put degree highlighted instead of radian, because if you forget that, all of your answers will be wrong. Alright, so let's move on to word problems example here. We will be solving for work equals force cosine theta times distance. Diagram A. We have a 100 Newton force pushing the 15 kilograms. So force and distance are in the same direction to the right. You will be using scenario number 1, so your cosine there will be equal to 0. So if you plug that in your equation, you will have F is 100 times cosine 0 times the meters, which is 5. So 100 cosine 0 times 5 will give you 500 joules. You can try and get your calculator and plug that in so you can practice. Okay. Diagram B. Now we have an angle pulling horizontally. Our angle from the horizontal is 30 degrees. So you plug in your equation, force is 100 times cosine 30 times 5 meters will give you 433 joules. Third example. This one is lifting up an object, going up, so the distance is also going up. Normally, if the object is lifted up, the force is not going to be given, but you will be given a mass. So since the mass is being pulled by gravity, you can solve for your F, force, using the equation. Mass times the pull of gravity, which is taken from the second law of acceleration from Newton. So mass is 15 times 9.8. And 9.8 come from? It's constant. Okay, we did that with projectile and in a lot of our problem set. So 15 times 9.8 will give you 147 newtons. Alright, plugging that in on your work equation, 147 times cosine, it will be a 0 degree because force is in the same direction as distance. So times 5 will give you 735 joules. Alright, last 2 examples down here. I'll start it, and I want you to plug it in your calculators and put your own answer. So for scenario D, the distance is in opposite direction as the force, so we said that the cosine there will be 180 degrees. And remember, if you plug that in your calculator, you will come up with a -1 value, so I would expect an answer here which is negative. Go ahead and plug in the values and see what's your answer. For the last example, our force is making a 90 degrees to our distance. So our cosine will be 90 degrees, and we know that that's 0. So if you plug in everything, guess what your answer is? Alright, remember to turn in when you're finished with 73. The next video, I will help you with page 74.